Welcome to section 2 of the Attack Flow online training using Attack Flow Builder. If you missed it, the first section was a broad overview of Attack Flow, and if you haven't watched it yet, I encourage you to go back and look at that now. In this section, we'll start to look at how to use the Attack Flow Builder tool and some of the basic building blocks of an attack flow. In the next section, we'll do a hands-on exercise where we build an attack flow together. So first, let's start by understanding how the Attack Flow Builder tool works. The Attack Flow Builder tool is a web application for diagramming attacks. As we discussed in the first section, this is an open source browser-based tool. It is similar to Microsoft Visio in that you create boxes and connect them with lines. You use this tool to create, edit, export, and present your flows. And as a reminder, the data in Attack Flow is private. It stays in the browser on your computer. We never collect it or share it. And for additional assurance and privacy, this can be hosted inside of a Docker container at your own organization. Next, we'll look at some of the key user interface elements. First, at the top of the application, you have a menu bar. This has typical menus like File and Edit. This is where you'll find the options for creating a new flow, opening a flow, saving a flow. You have options like Cut, Copy, Paste. In the main area underneath the menu bar, this is the canvas where you view your attack flow. You can pan around and zoom in and out. You can also select items in the canvas. When you select an item in the canvas, its properties will appear in the right sidebar, and here you can edit them. As attack flow runs, it continuously validates the work you're doing. If it finds any problems with your attack flow, it will be highlighted in this problem panel in the bottom right corner. If you see a problem, just click on it and attack flow will zoom you right to the affected item. And the final user interface component is this footer, which will show you some contextual information like how many items you have saved, and at a glance, whether your attack flow has any validation issues. So that is what the builder looks like. And now we'll start looking at the basic building blocks of attack flow. The most fundamental element in an attack flow is the action. The action is the backbone of the flow. It describes what the adversary is doing at the TTP level, meaning tactic, technique, and procedure. Every action needs to have a name and ideally should have a description as well. The name is displayed in the blue header and the description is displayed underneath it. Every action can be mapped to a MITRE attack, tactic, and technique, but it is not required to do so. This slide shows the properties that exist on each action. We've already talked about name, TTP, and description. You can also see here a confidence, which allows you to specify how certain you are in the underlying intelligence, as well as the execution start and end, which are the timestamps associated with when this activity was observed. This slide describes the various confidence levels that are available to you in attack flow. These values map onto a numeric range from 0 to 100, which is consistent with how STIX operates. If you want to learn more about how the confidence intervals work, take a look at our website. The most important thing that you can do with actions is to connect them to one another. When an action is connected to a subsequent action, the first action represents a precondition that must be satisfied. In this example here, the exfiltration over C2 channel cannot happen until the data collection from local system is successfully completed. As a reminder, the arrows in attack flow are not chronological. They are illustrating chains of cause and effect. The next building block is the condition. The condition is used to model how the adversary makes decisions or how they respond to failed attempts. The description is a human readable text that is displayed in green. And optionally, you can use the STIX pattern language for machine readable conditions. Unlike other objects in attack flow, conditions have two different types of output. One is true and one is false. The best way to understand the condition block is to look at an example. In the NotPetya flow, the malware checks if the Kaspersky antivirus is running on the system that has just infected. If it has, then it takes the true branch of this green condition block, and the malware corrupts the master boot record. If Kaspersky is not present on the system, then the condition takes the false branch and the malware installs a malicious bootloader for persistence. The condition block can also be used as a way to annotate complex technical topics in a flow. Going back to the NotPetya example, the malware has two different approaches that it can use for privilege escalation. One is LSAS memory dumping and the other is token impersonation. Now, to a reader who doesn't understand these fairly sophisticated Windows concepts, it may not be obvious what is happening in the two top blocks. We add the condition in the middle here so that we have an opportunity to provide a human readable explanation that just says the user escalated to a different account. You'll notice here that we only use the true output and not the false output because in this case, the condition is just used to explain the situation. The next building block is the operator. Operators allow multiple attack paths to converge. The OR operator requires any one of its inputs to succeed before the next action can continue, while the AND operator requires all of its inputs to succeed before the next action can continue. Here's an example of the OR operator in the NotPetya flow. So once again, looking at that privilege escalation technique, we could use an OR operator here to make it clear to the reader that the malware only needs one of these two approaches to succeed in order to move on to the next step, which is lateral movement with the privileged credentials. Now here's an example of using the AND operator. This is excerpted from the Tesla flow. In this case, the adversary has several actions they need to perform, such as positioning their infrastructure, setting up a non-standard port for defense evasion, and also deploying a container. If all three of these actions execute successfully, then they can move on to the last action, which is their impact, resource hijacking. Operators can be confusing for new users to attack flow, and I want to point out an anti-pattern that I've noticed in some of the flows. If you have an operator with a single input, then it doesn't do anything. We sometimes see users doing this due to a misunderstanding about operators, wherein they think that in order for A to point to multiple outcomes, B, C, and D, that an operator is needed to create multiple outcomes. But it's actually totally legitimate and preferred to directly connect A to B, as well as A to C and A to D in a situation like this. The final building block of an attack flow is the asset block. Assets are very generalized. They just contain a name and description in order to be as flexible as possible. Assets represent information systems, data, or the users involved in an attack. Now, if you want to add structured data, such as a username or whether an account was privileged, you can do that using STIX objects, which we'll take a look at shortly. By convention, if an arrow points from an action to an asset, that means that the action modifies the state of that asset. Whereas if the arrow points from an asset to the action, that means that the action depends on the state of the asset. One anti-pattern that we have observed with users who are new to attack flow is to insert an asset in between two actions, as opposed to the previous slide where the asset was off to the side. Inserting the asset in between the two actions is technically allowed, but is not recommended. Instead, actions should connect to other actions, conditions, or operators in a continuous chain, and no other node types should come between a pair of actions. If you want to add structured data to an asset, you can do so using STIX objects. Here I have an asset that refers to multiple user accounts, but as we mentioned earlier, the asset block only contains a human-readable description. So I've added two STIX objects on the side here that convey the username and whether or not these are service accounts and privileged. So far, we've talked about the basic building blocks of an attack flow, the action, operator, condition, and asset. But attack flow also has complete support for STIX, which is the Structured Threat Indicator Exchange language. And so I want to walk you through what that looks like and what it means. The STIX language defines 18 different domain object types as well as 18 cyber observable types. All 36 of these types are available in attack flow. These objects can be added to your flow and connected to other objects with lines just like any other node. You can also export your flow to a STIX bundle or import STIX bundles into your flow. Now let's revisit the example we just had of an asset being enriched by two user account objects. The user account is defined in the STIX specification. It's represented by the user account observable type. Here's another example of a useful STIX type. This is the vulnerability node. The vulnerability allows you to link an action to a CVE number and provide a description of what that vulnerability is and how it is used in this breach. Just like the other attack flow nodes, you can click on a STIX node in the canvas and then edit its properties on the right side. This is an example of the file object in STIX, and you can see that it has properties like name, file size, and hashes that can be set in a variety of algorithms such as MD5, SHA-1, SHA-2, etc. Attackflow is actually a really nice editor for creating STIX data because the validator will point out any mistakes you make. For example, on this file object, we have tried to create an MD5 hash with the value AAAA, but the validator has noted that that is actually not a valid syntax for an MD5 hash. This makes it easy to find data quality problems and correct them. Now, let's see all of these concepts in action with the demo of the Attackflow Builder. I encourage you to follow along, and if you fall behind, pause the video so that you can catch up. To get started, we need to go to the Attackflow Builder. You can get there in a few ways. The first way is to use our shortcut ctid.io/flow. This will take you straight to our project page, and then in the table of contents, select Builder, and then scroll down on the Builder page until you see the Open Attackflow Builder button. If you click that, it will open up a new tab. If you're a power user and you just want to go straight to Attackflow Builder, we have another shortcut, ctid.io/AFB, short for Attackflow Builder, that will take you straight there. Now in practice, a lot of times you're going to want to be able to start with an existing flow. And if you want to do that from our website, you can go to the example flows page, pick out one of the flows that you're interested in, for example, the Black Box ransomware, and then click the Open Attackflow Builder link, and it will take you straight there. Now let's try some basic navigation of this attack flow. First of all, I can move around by just clicking anywhere on the canvas and dragging. I can use my mouse wheel to zoom in or out. You can also zoom in by double clicking anywhere on the canvas. You can select any item by clicking on it, and you can see that its properties appear on the right side properties panel. You can select multiple items by holding down the Command key on Mac OS or the Control key on Windows. Another way to select multiple items is to hold down the Alt or Option key and drag out a rectangle to select multiple items at the same time. Once you've selected some objects, you can drag them around on the canvas to move them to a new position. You can toggle from dark mode to light mode using the View menu here. Now let's take a look at how you can edit the properties of an action. When you select an action on the canvas, its properties appear in the right side properties pane. And as you type in this property, it will update on the canvas in real time. Underneath this, you can map this action to a tactic and technique. We've got examples here using MITRE ATT&CK, but you can use any TCP knowledge base that you prefer, or just leave these blank. You can edit the description field. You can assign a confidence level in the underlying intelligence, and then you can specify the timestamps when this activity started as well as when it ended. Now let's take a look at how to create a flow from scratch. Over here, I have a new tab with the builder open. The first thing you'll notice is that we have this splash screen that prompts us. We can create a new flow or open an existing flow, or if you were working on a file earlier and you accidentally closed your tab without saving it, this will give you a chance to recover that work without losing it. In this case, I'm going to click New Flow, and this will just give me a blank flow. If we take a look at the bottom right corner in the Problems pane, we'll see two problems right now. The first one says Missing Required Field Author Name. So I'm going to go to the properties for my flow here. I'm going to click the author arrow, and I'm going to specify this information, including a name, the type of authorship, and contact information, which is optional. Once I've entered this information, that problem has gone away from the problem pane. But now we can see the second problem, which is that the flow must have at least one action in it. So to create an action, come onto the canvas, right-click anywhere, and then go to the Create menu, and then Attack Flow, and then Action. And this will create an empty action for you. The next thing you'll notice is that we now have a new error saying Missing Required Field Name. Now, if you ever lose track of which item has an error, you can just click on the error in the Problems pane, and it will highlight and zoom you into the affected item. So now I can go ahead and give this a name. And now you can see that the problem panel has cleared up and we now have a valid attack flow. I'm going to repeat the process to create one more action. And you'll notice as I create these that any properties that are left blank in the side panel are not displayed on the canvas, which means if there are features that you're not using in your flow, such as the execution start and end timestamps, those aren't taking up space in your visualization. They're only visible when you're looking at the properties panel. Next, I want to hook up an arrow pointing from the first action to the second action. To do this, as I hover over an action, you'll see all of these anchor points. I'm going to click on any one of these and start to draw out a line. And then when I get close to the other action, it will highlight its anchor points. I can choose any of these anchor points and drop my line onto it. Once you've connected two actions with a line, the line will follow those actions wherever you move them. One more thing I want to show you is how to reuse pieces of one flow into a new flow. So if I go to an existing flow, I can highlight a few items like this, and then go to Edit, Copy, and then in my new flow, I could go Edit, Paste, and it will drop them into my new flow just like that. And now these items can be wired up into my new flow. This is a helpful way to reuse items across multiple flows and can be a major time saver. This brings us to the end of section 2, where we got an introduction to the Attack Flow Builder tool and also discussed the basic building blocks of an attack flow. In section 3, we'll turn our attention to a realistic, hands-on example of building an attack flow from scratch. Visit our Get Involved page to learn how organizations and individuals alike can work together to advance our common goal of expanding threat-informed defense. And follow us on LinkedIn for future updates on attack flow and other major projects such as Mappings Explorer and Summiting the Pyramid.